All right, so we're going to help you get ready for this mini check on inverse trig notation as well as composition of trig. And we're going to use sheet 311. Now, I'm going to help you get started with this sheet just so you have a little basis for each of these three categories. So if you want to kind of get started with me, we're going to do three problems. I'm actually going to work backwards. We're going to start with number 9. Now, number 9 is a composition. And whenever you have two trig functions, it always fits into this model or this method where you're going to start with the trig function on the inside. Now, the trig function on the inside, in this case, is an inverse tangent. And so that's referring us to certain dimensions of a triangle. Since tangent is y over x, that means that we have a triangle that has a y value of 1 and an x value of 1. Now, the good news is that you will always draw that triangle in the first quadrant when you're doing a composition, which again is like number 9. So when I draw that triangle in the first quadrant, I'm able to identify the x as 1, the y is 1, and then I'm going to need to think about the r value. Now, you can use the Pythagorean Theorem to get the r value. In this case, 1 squared plus 1 squared equals r squared, which means that r squared equals 2, or the square root of 2 is equal to r. Now, this was a 1 root 2 from the beginning, so you could have also just said root 2. Now, here's the thing. When you do a composition of trig, your answer ends up being the outside trig function. Now, cosecant, you'd have to remember, is r over y. R over y. So I'm basically going to grab my r value, I'm going to grab my y value, and bingo, I have my final answer. So when we do a composition of trig, our answer ends up being the dimensions of the triangle. Compare that to a inverse of trig, like number 5. An inverse of trig, well, that's a whole different problem, because when you have an inverse statement, that refers you to angles. Now remember, arc just means angle, or you could see it written as the inverse, which means angle, or you could see it written without the inverse, where we would say the secant of x is equal to -2. Now here's the thing, all three of those statements mean the same thing, so you don't need to rewrite it. You can just start with what you're given. I'm going to go back to what I'm given so that you understand that I can do the problem from the beginning. Now remember, secant is r over x. So that means I want to think about -2 as being over 1. -2 over 1. Now, this creates a little bit of a problem. And the problem is that the r value is negative. We can't have a negative r value. So what we're going to have to do is we're going to have to not change it, but we're just going to have to reinterpret it. That is, the negative sign is going to get interpreted as being on the x. Now, that's completely legal because it's still equal to -2. It's just that we're going to interpret it as 2 over -1. Okay, what do we mean interpret it? Well, what I mean is triangles. Now, the hardest thing for kids with this type of problem, that is using a triangle method, is knowing where to draw the triangles. And the answer always has to do with positives and negatives. In this case, we have a -x. Now, if you have a -x, what you want to be doing is thinking about a triangle with a -x. And that triangle is going to have to be over here. You see, when you go over here, you have a -x value. But it also is true that this triangle is also over here. And so both of those triangles satisfy the original given. And to say it again, the original given has a -x value. Now the r value is 2, so we can put that in. But we're going to need to think about the rest of this triangle as being a 1, 2, root 3. Okay, now once I determine that it's a 1, 2, root 3, then I can get to the business of angles. Okay, now you have to understand the answer to this problem is an angle, or in this case, angles. So we're going to have to know what this pink angle is right here. And you just need to know that in a 1, 2, root 3, that the pink angle, which is across from root 3, is 60. Likewise, this pink angle is 60. Now, my final answer is not 60, but my final answer is going to be the rotation to get to that terminal side. This is the terminal side. It's the hypotenuse. The rotation to get to that terminal side is my answer. And that's why we record 120. And take a look at how I rotate to the other terminal side. The other terminal side is right here, but I'm going to rotate from 0 all the way over here. So again, I started at 0, and that's why I'm going to write down 240. Now, both these pink angles would be the answers to number 5. Okay, now that's a triangle method. And finally, we're going to compare that to a graphing method. Now, when you look at number 2, it's an inverse statement, but anytime you have an inverse statement, the answer is always an angle. If we're going to use a graphing method, what we want to be careful is that we graph the right thing. This is usually what students have a little trouble with, is what to graph. And as I want to remind you that no matter what the notation says, you're always going to graph an old friend. Now, who's an old friend? Well, it's either going to be the sine of x, the cosine of x, or the tangent of x. In this case, since it's a sine problem, we're going to graph the sine of x. Now, notice that I didn't graph the sine of 0. Notice that I didn't try to graph the inverse sine, which although that works, or I see a graph, it's not going to help us with our answer. So there's a couple no's in this problem. And one of those no's is that you are trying to graph 0, or the sine of 0. Or maybe you're trying to graph the inverse in some way. In fact, all you really need to do is graph an old friend. And the old friend is just going to be y equals the sine of x. Now remember, when you graph on Desmos, you do need to change to degrees. So we click degrees. And we also want to make the x-axis go negative 360 to 360. That's just a common x-axis that's going to help us to be able to easily get our answers. I think I also told you to change the y-axis to negative 4 to 4. Okay, now when you graph this, what's going on here? I'm kind of in a funny window. I'm going to just refresh this because sometimes it gets kind of a little wonky. I'm going to change it so that I'm not so zoomed out. All right, so same changes, but I just kind of reset the computer. Now, here's an old friend. Here's the sine wave. And what I'm trying to do is I'm trying to go to a value of 0. Now, sometimes students say, what do you mean go to a value of 0? Well, I'm talking about a y value. Now, a y value is going to occur, a y value of 0 is going to occur when you were along the x-axis. So here's a y value of 0, here's a y value of 0, and here's a y value of 0. So if I want the value to be 0, I'm talking about the y value. And so you can do a little bit of tracing, you can do a little bit of dragging. Remember, to do that, you have to click on the graph, and then you can drag these dots. In this case, I actually can see that the dot is at 0, 0. But I can also drag over here to this point, which is 180, 0. Notice that the y value is 0. And then over here at 360, 0. Once again, notice that the y value is 0. Okay, that's why my 3 answers for this problem would be at 0, 180, and 360. Now what I'd like you to do is look at the rest of the problems on that sheet. And when you have about 10 minutes to go in the period, you should be switching gears to the mini check. The back of the sheet, I'm going to encourage you to look at that after the mini check. Some of those problems are a little bit of extension questions, and they will help you to get ready kind of for our last couple days in this chapter, and I'll have you turn in the paper tomorrow.